All right, strap in, everyone. We're going deep on some brand new AI research today.
Oh, yeah.
This one's all about the Byte Latent Transformer.
BLT.
Yeah, BLT. And from what I can tell, it's really kind of shaking things up in the world of language models.
Well, yeah, and what I find really interesting is that it goes right at a core problem in how AI understands language, the problem of tokenization.
Yeah, tokenization. I saw that word a lot in the research papers. But to be honest, I'm not totally clear on what that means.
Sure.
Can you kind of break it down for us, for folks who aren't, totally up on all the AI jargon?
Imagine that you're reading a book, but you can only look at like chunks of words instead of individual letters. So you're probably going to miss some important details, right?
Right.
Well, that's basically what tokenization is doing.
Okay.
It's taking those bytes, those like fundamental pieces of digital information, and kind of grouping them into these predefined chunks that we call tokens.
So it's like we're forcing the AI to wear blinders when it comes to language, basically.
Yeah, pretty much. And that can actually cause a whole bunch of problems. The research pointed out how tokenization can lead to biases, inconsistencies, even trouble understanding things like different writing styles or different languages.
Wow.
It's like we're trying to cram the entire universe of language into these pre-made boxes, and it just doesn't really fit right.
So it sounds like tokenization is...
It is.
It's definitely a problem.
Definitely a problem.
So that's where BLT comes in, kind of like the hero of the story.
Yeah, exactly.
So how is it approaching things differently?
BLT ditches that whole tokenization thing entirely.
Oh, wow.
And it goes right to the source, right to the raw bytes. It's almost like giving AI the ability to read at the level of individual letters and characters, just like we do as humans.
Wait, so wouldn't that totally overload it with information?
Well, that's where BLT gets really smart. Instead of looking at every single byte with the same level of importance, it uses this system called dynamic patching.
Dynamic patching.
Dynamic patch. Sounds kind of complicated, but it's actually pretty cool.
Right.
Imagine BLT is like a detective, right? Scanning through a text and figuring out which parts need the most attention. It groups these bytes together into what we call patches.
Okay.
And the size of each patch changes depending on how complex the information is.
Oh, interesting.
So simple, straightforward stuff, it gets bigger patches.
Okay.
But the parts that are harder to understand, those get broken down into smaller, more manageable pieces.
So BLT can, focus its energy where it matters most.
You got it. And it uses this concept called entropy to decide where to focus.
Entropy. Like in physics.
Kind of. But in this context, entropy is all about how much uncertainty there is.
Okay.
Think about reading a mystery novel.
Yeah.
You have no clue what's going to happen next, right?
Right.
That's high entropy.
High entropy. Okay.
But if you're reading like a nursery rhyme or something, the next word is pretty predictable.
Yeah.
Low entropy.
Low entropy.
So when BLT hits a section with high entropy, it knows to make a smaller patch because things are about to get interesting.
Makes sense.
And this is one of the big reasons it can do so much with way less processing power than those old token-based models.
So we've got like an AI detective scanning text, making these dynamic patches based on how unpredictable things are.
That's BLT.
It's wild.
Yeah.
But I'm still trying to picture how it actually works. What's going on under the hood?
Well, the structure of BLT is really quite fascinating. They actually described it as a 3-part symphony in the research.
Ooh, I love a good analogy.
So we start with the local encoder, which is like the first movement of the symphony.
Okay.
And that takes those raw bytes and turns them into these dynamic patch representations that we've been talking about.
So it's kind of setting the stage.
Exactly, setting the stage. Then we come to the star of the show, the latent global transformer.
Ooh, fancy.
This is where all the magic happens, really.
Okay.
It analyzes those patches, figures out what they mean, and how they all connect together within the text.
So it's like the conductor of the orchestra bringing everything together.
Perfect analogy.
Yeah.
And then last but not least, we have the local decoder.
Okay.
This is the grand finale. It takes all those process representations and turns them back into something we can understand. Basically, a sequence of bytes that represents that original text.
So it's like the audience giving a standing ovation at the end of this incredible performance, right?
Exactly.
But it feels like there's got to be more to it, right? Is that really all there is to this symphony?
There's one more really important piece to this whole thing that we haven't talked about yet.
Oh.
Hash n-gram embeddings.
Hash n-gram embeddings.
That's how BLT goes beyond just recognizing those individual letters and actually starts to get the context. Like, understanding how words and phrases work together.
Like we do.
Just like we do.
Yeah.
Think about it like this. Imagine you're trying to figure out what the word read means.
Okay.
Just by itself, it could be the present tense or the past tense. But if you see it in a sentence like, I read a book yesterday, you instantly know it's past tense because of all those words around it.
The context.
The context. And that's what hash n-gram embeddings let BLT do.
Okay.
So instead of just looking at the individual bytes like, ooh, eed, it can also look at those combinations like real eed. It's like giving BLT the ability to see the whole picture instead of just those tiny little pieces.
Yeah, zooming out a little bit.
Exactly. So BLT is really reading between the lines in a way.
That's cool. But what about scaling? How does BLT handle, bigger chunks of text? Like, could it understand a whole book?
That's actually one of the coolest things about BLT.
Oh, yeah.
It scales incredibly well. With those old token-based models, they really struggle with longer sequences because the processing power just goes way up.
Yeah.
But BLT, because it uses patching and entropy so efficiently,
Right.
it can handle these huge amounts of text without even breaking a sweat.
So it's like BLT has way more stamina than those other models.
Exactly. It can run a marathon while the others are, out of breath after a sprint.
Nice.
And this has huge implications.
Yeah.
Imagine training BLT on these gigantic data sets, like whole libraries full of text. The potential for really understanding and generating complex language it's just amazing.
It's pretty mind-blowing.
It is.
But let's get down to brass tacks here.
Sure.
We all know that AI sometimes has a hard time with messy, unpredictable data, the real world.
Yeah, absolutely.
So how does BLT do in those situations?
That's where focusing on those raw bytes really pays off. Think about things like social media posts, online forums, even old documents that have been digitized.
Yeah.
They're full of typos, slang, weird formatting. It's like a free-for-all.
The Wild West of language.
Exactly. And those token-based models, they really freak out when they see that stuff.
Yeah, I bet.
Because all their neat little tokens get messed up.
Right.
But BLT can just cut through all that noise. Yeah. Because it goes right to that byte-level information.
We can still figure out what's going on.
Exactly.
It's like BLT has X-ray vision for language or something.
I like that.
That can see through all the chaos.
They actually tested BLT on intentionally corrupted data in the research.
Oh, wow.
And it blew the token-based models out of the water.
Really?
Yeah. Really shows how robust and adaptable it is.
It's impressive.
It is.
So BLT can handle the messiness of the real world?
Yeah.
That's a huge plus.
It is.
But there's one more thing that really caught my eye in this research.
Oh, yeah.
This idea of like byte AV-fying existing models.
Oh, yeah. That's a clever one.
What exactly does that mean?
Well, we've already got these huge, powerful language models out there, right?
Like Llama 3.
Like Llama 3, exactly.
Right.
But they're all built on that tokenization system.
Right. So what if we could take all that knowledge, all that understanding of language that they've learned, and move it over to a BLT model?
Bingo. It's like taking the brain of a supercomputer and putting it into this brand new, more efficient body.
Did they actually try that?
They did. The results were really exciting.
Okay.
They found that if you start a BLT model using the weights from a pre-trained Llama 3 model, it just takes off. The performance gets a huge boost.
It's like BLT's getting a head start in the race.
Exactly. It gets to benefit from all that work that's already been done with those massive token-based models.
That changes everything.
Yeah, it does.
It means we don't have to start from scratch with BLT.
Right.
We can build on all those successes and really speed up its development.
Exactly. It shows that BLT has the potential to not just change how we think about language models, but also to actually use and improve on all that progress that's already been made.
It's like BLT is standing on the shoulders of giants.
I like that. Standing on the shoulders of giants.
Okay, so we've talked a lot about BLT, everything from those limitations of tokenization to how BLT actually works and how well it performs.
It seems like BLT really offers a whole new perspective on building these language models, making them more efficient, more robust, more adaptable.
Yeah, it kind of feels like we're seeing a paradigm shift in how we think about AI and language,
I think you're right. Moving away from those constraints of traditional tokenization opens up a whole new world of possibilities for AI. It can really start to understand language at a deeper level with all those nuances.
This idea of an AI that can read and understand just like us, down to those individual characters, it's pretty amazing, but also a little bit unsettling, maybe.
It definitely brings up some big philosophical questions, If AI can really grasp language like we do, what does that mean for communication, for creativity, even for consciousness itself?
Those are some really deep questions.
There.
But let's bring it back down to earth for a second.
Okay.
Does BLT have any limitations? Is it like the perfect solution?
Well, like any new technology, BLT still has some hurdles to overcome. The research pointed out that we need to do more work on how to scale BLT effectively. Finding that sweet spot between the size of the model, the size of those patches, and how much data we use to train it, that's crucial.
So we can't just make everything bigger and assume it'll all work out.
Exactly. Those rules that we've figured out for token-based models, they might not apply the same way to BLT. We're in uncharted territory here. There's still a lot to discover.
So from a more practical perspective, are there any challenges in actually putting BLT into practice? Is our current technology even ready for this whole byte-level revolution?
That's a good point. Most of our software and hardware is built around those token-based models, right?
Yeah.
So to really embrace BLT, we might need to rethink things on a very basic level. We might need new tools, new algorithms, even a new way of thinking about how we process data.
So it's not as simple as flipping a switch and suddenly everything is byte level.
Not quite. There's a whole ecosystem that needs to adapt along with BLT.
It's a big shift.
It is.
But it seems like the potential benefits of BLT are huge, worth all that effort.
I think so too. We're talking about a fundamental change in how we approach language AI. It could lead to some major breakthroughs in all kinds of applications.
So for our listeners out there, why should they care about BLT? What's the takeaway for them?
Well, just think about how much language models already affect your life. Chatbots, virtual assistants, search engines, translation tools, content creation. It's everywhere.
It's hard to imagine life without them now.
Right. And as these models keep getting more powerful, more adaptable, more efficient, they're going to revolutionize even more aspects of our lives. BLT is a big step toward that future, a future where AI can understand us and interact with us in ways we never thought possible.
A future where language isn't a barrier between humans and machines anymore, but more like a bridge that connects us in deeper ways.
I love that, a bridge that connects us. This research on BLT is just the beginning. I can't wait to see what comes next, how it shapes the future of AI and how we relate to technology.
That's our deep dive into the Byte Latent Transformer. It's been a fascinating journey, and we're excited to see what the future holds for this incredible technology. Until next time, keep exploring, keep learning, and keep diving deep.